All
All
right.
right, we're live.
All right.
All right, good morning, everyone. I'm Shannon Williams from Acorn. It's great to be here with you all on this Friday morning from California. With me today, as always, is my co-founder here at Acorn, Darren Shepard, along with one of our key engineers, Torsten Klein, who is joining us from Germany. Torsten, thanks for giving up your Friday night to chat about GPTScript and demo some of your cool new latest work. We're really excited about today's discussion. It's been now about a month and a half or maybe 2 months since we first introduced GPTScript, and we've been kind of rolling out on a regular basis new features. But this is the first new feature we're releasing that kind of starts to build towards some interesting new capabilities we're hoping to roll out sometime in May or early June. So Darren, maybe you want to talk a little bit about this knowledge embedding and retrieval technology that we're talking about today.
Yeah, so it's like GPTScript. Like we focused a lot on. I mean, kind of like what initially intrigued me, I guess, with what we could do with GPTScript was a lot of like AI automation stuff, and so we've done a lot with tools and calling tools and stuff like that. But like one of the super big use cases of AI is kind of like understanding data, ingesting data, comprehending data, or whatever. So it's like you hear this term thrown around all the time, RAG. It's one of like the most common use cases. And so as we've kind of gotten a lot of the basics of like, how do we structure GPTScript and do automation, call tools, how to build tools, like all that stuff, we're now looking at kind of like the larger set of all the problems we need to kind of solve in the AI space. And so one of them is this knowledge use case, which is just basically like an LLM has, it has a bunch of like existing knowledge. It's been trained on all this data. So it's like, it has a bunch of things that, just kind of like a general person would know, but it's also super smart. It knows all these other things. But what about things that it couldn't possibly know, which would be like, your own internal systems or this thing that just came out last week or whatever, so it's like, how do you basically add additional knowledge for things that it wasn't initially trained on? So it's like, that's kind of the basic area where we've been, looking at, seeing what we can do with, with GPTScript and stuff.
And it fits in pretty cleanly with the direction we're going. I mean, the whole idea behind GPTScript and what we're building towards is, the ability to create applications, right? Create AI-powered, functional capabilities. And a lot of what we've been doing right now is really has been on the automation side. It's been on things like vision. It's been on generative kind of use cases. So extending this to, creating knowledge elements that can be then paired with those allows us to create more and more interesting applications, I assume, especially as we get into, developing customer relationships, one-on-one communication, customer service, that type of use cases. A lot of things we've been talking to people about who are using GPTScript already. So yeah, so tell us exactly what this is, Darren, and sort of where you expect it to be going.
Yeah, so one of the technically what we're doing is, so one of the approaches to add knowledge. So it's like when you think about LLMs, there's what it's already trained on, and then there's the information you can give it like as you're talking to it. So it's kind of like the current session. It's called the context. What's the context length? What's kind of a context window? How much? So right now, a lot of the open source models are like 8K, 32K, something like that, of like information that you can kind of give it on demand. Google, they can go up, like with Gemini, they can go up to 1 million tokens, which is a token is about 4 bytes, something like that. So you can multiply that. So they can actually get quite a bit of information kind of in there. But so you have this problem where it's like, if it hasn't been trained on the data, you can only tell it like on demand so much information. And then also, even if you have like 1 million tokens, like it's still not super efficient to always be like passing it information every single time. Like that costs money and it slows it down a little bit or whatever. So one of the technical approaches that people have kind of figured out in the AI space is basically to index a bunch of content and use similarity-based searching. So it's semantic searching. So you have to index a bunch of data and put it into a database, which is a vector database. And then you can just take a query, like the way you would search on Google, like you have a, ask it some question, and it's going to use, kind of a semantic understanding of that query, and then look in that data and then give you results. So you take this search-based approach. So if you ask an LLM something, you can first send that query to a vector database, and it will give you back a bunch of results of saying, like, here's a bunch of information that's related to this query. Once you have that information, you pass that with like your query to the LLM. So it has like up-to-date, interesting information. So then it can digest that information plus your query and then form it into a logical response. And so this is like kind of like the current approach on how people, add knowledge to LLMs. So this is pretty much like the what RAG is, like what most people are referring to when they say RAG. RAG is a retrieval augmented generation, right? And so that's like a larger kind of very generic approach. But when people, most of the time when they're talking about it, they're thinking of this specific use case of basically how do we put a bunch of data into a vector database, and then anytime that we're talking to the LLM, let's actually query that database, get that additional information, pass it to the LLM at the same time so it can form a better response. So that's kind of like the big technical thing of like, how can we kind of do that? And this process of indexing all the data is like, it depends on like your use case. Cause like this can be a huge project in and of itself of like, your company has all of this data, like find all the data, try to index it. What's the important like fields? And it's like, you can spend a lot of time doing this, but what we were looking for is we wanted to focus on a kind of a little smaller use case where it's like smaller data sets where it's like, I want to train, I want to create like a chatbot or a tool that just knows about like, this program or this system. So it's like, I have some existing documentation of how this works. Can I just, kind of index that very easily? And so instead of creating kind of like these kind of like massive, difficult projects that require like a massive vector database where you have like gigabytes or terabytes of data and it's this huge effort and everything, can we look at kind of like the smaller, simpler use case where there's kind of like there's a lot of these like kind of smaller things where it's like, I just have a PDF, some text files and whatnot. Can I ingest those? But then what we thought was really interesting was how can we pretty much like embed that knowledge with the tool? Because like the whole thing with GPTScript. So the cool thing is like we can write these GPT scripts and then we can like package and share those. So it's like, instead of me just sharing like the tool, can I share the tool, but it also brings the knowledge with it? And it's not like I have to have like a database server running somewhere. And so it's like, so it's this really cool idea of like, can we attach knowledge to a tool? And so like, this is kind of a different approach of what other people have been taking, because a lot of the work is on the kind of like the much larger use cases. But so it's like, what we wanted to do was kind of like more of like the SQLite approach to knowledge. And so this is what Torsten has been working on, and he'll show, kind of a demo of this. So what he's building is kind of the knowledge tool, which is a tool that you kind of run out of band. Well, it's kind of, it works both, like use it for querying, but the knowledge tool is like basically what you do is you have all your information already, just, PDF or text files or whatever. You run this tool and it will ingest all of the data and create a database file. And so think of it more like SQLite. Right now we're using SQLite plus this other Go library. We'll most likely switch the whole thing to SQLite. Like this is all still a work in progress. But so it's like you ingest all this data into a database, but it's really just a file. So don't think of like a database server that you need to run and manage. It's just more of just like a file. I have a file database. And so when I build my tool, I can now basically just put that file with my GPTScript tool, check that in, like put that in GitHub. So when somebody uses that tool, it comes with this knowledge that you already built up. And there's a bunch of other like things where it's like, in order for this to work, you have to run these embeddings, which is like turning the data into these vectors of numbers and whatnot. Like that's like a process in and of itself. And Torsten was showing that. So it's like, that's something you kind of want to do offline anyways. Like you don't, with this AI stuff, you don't really want to be like, it's like on demand, like dynamically go, it's like kind of like go to this website and index all the data and then ask a question. Like that's very slow and expensive. Like you really want to index it once. And so it's like you can build up these small little databases and ship them with the tool, and you can keep adding to that knowledge over time. And then it's just like a new version of the tool. Yeah.
So an example of somebody's, knowledge would be, let's say I'm the World Wildlife Foundation. I have all of my annual reports and excuse me, impact assessments and my website, and I feed all of that in, and all of a sudden now I have this data set that I've indexed and vectorized, and it is, effectively detailed information about my organization. And I can use that with other types of generative AI, for example, to, educate very quickly the LLM on the latest information about my org that maybe it wasn't trained on because it was trained 6 months earlier or a year earlier or something like that. And query it, build reports, anything like that from that new set of data that I've shared with the tool.
Yeah.
Okay. Awesome. Well, Torsten, if you're ready to share your screen, let me pull it up here. And yeah, we'd love to see how this works.
Absolutely. Thanks for the good intro. Oh, well, Shannon, what better way is there to spend a Friday evening than demoing a knowledge tool?
Beautiful spring night. I'm sure I can think of a nice beer garden you'd probably rather be in.
Absolutely. But the good thing is I can go there after this. So.
That's right. It looks like it's still light outside even. So I don't.
Yeah, it is. Summer is coming. All right. Yeah, so I've been building the knowledge tool for a couple of days or a couple of weeks now. And as Darren mentioned, we're using an embedded database to store everything from the actual file index, so recording what files you already ingested and what documents and what knowledge bases you created before. And right now we're using a separate vector database, which is also embedded. So it's just a bunch of files that you could possibly copy around on a USB drive and plug it into a different PC and just query your data there as well. And you don't have to reindex every time. And like some of the cool use cases that I personally use it for during testing is just querying over all my insurance documents to figure out what the current policy is without having to look what's latest document and what are the terms in there. All right. Well, this is just built in Go, so it's a single binary that you can build yourself or just download from our GitHub repository. And Darren already mentioned we have two modes to run this in. One is like the standalone client mode, so you can just run it as a CLI and it will create the database and serve the database internally for you. Or you can run it in client server mode. So if you want to have it as a long running application, you can just run the knowledge server command. And there you go. You have a running server that you can query against or use REST endpoints to send your data to. I'm going to demo the standalone mode, and luckily Golang has this nice option to just run commands right from the markdown, so that's pretty cool. I don't have to type them out. So by default, we have one default data set, so that's a kind of a knowledge base, like a collection of knowledge and files that you ingested. So let's just list them out. Yep, we see we have a default one. And there's a bunch of data inside. That's not interesting. Most, like everything that the tool outputs is meant to be parsed by an LLM and not really by humans, because we're going to integrate it in GPTScript later on. Let's
and I wanted to throw out that it's like, so literally everything Torsten's showing here, like for the most part is like, I think pretty much all this came together in the last week or whatever. So like this is all like super kind of like raw and early, so it's not super polished or anything.
Exactly that. Yeah, that's true. All right. So you can see we have one data set. That's the default data set. There's nothing in there right now. So let's just go ahead and ingest the README that we have in the current directory. And that's fairly fast. You see, ingested it into the default data set. We can even see that. Oops, sorry. I can do typos even if it's prepared. So there we go. There's a bunch of stuff inside. That's because we are splitting the document, like the actual files into documents. We're tokenizing them according to make them more GPT-4 compliant right now. So we're using tick token for tokenization. And then we can just run a query against it. For example, which file types are supported. And let's quickly check the file. Oops, that's the wrong one. Well, looks like. So down here we have a list of supported file types. So it should spit those out. Let's see. Now what we will see is not the direct answer. So when we run knowledge retrieve, it actually gives back a list of sources in the JSON format that can be parsed by an LLM to actually generate the answer. That's what Darren meant before.
Yeah, so if you notice in this, it's hard to see because it's JSON or whatever. So it's interesting because LLMs understand JSON extremely well. So it's like this output, it's like it has the sentence, retrieve the following 5 sources from the query from the data set. So it's like LLM will understand this really, really well. It can basically be able to digest this. But you see in there this similarity score, which is like basically it's giving you the top 5 results of like, from this document, these pieces of text seem interesting to this query. So it's like, just here's interesting information about this. Like, I mean, it's like kind of what you've shown so far is kind of like, what's interesting is like, I think it's like I've looked into and started to learn all this AI and RAG stuff. It's like, when I got into this stuff, I'm like, well, this doesn't seem all that super interesting. It's just sort of, but the thing is like, it's like what open source has done and what we've been able to do with AI. And this is actually using, because it wasn't very obvious here, is like, in order to do this indexing, we're using OpenAI. There's this embedding model, and it's actually using a real AI technology to basically produce all this stuff. So it's like, what's interesting is like, it's kind of what we're doing here is what like Google already does. Like when you search for things, they do all this fancy searching stuff. But it's like now with open source, we kind of have like the kind of like the best of the search technology and stuff, and it's just kind of easily available to us. So it's like, so all we've really done with this tool is just basically ingested a little bit of data, and then we can search against the data, and we just get a bunch of hits. So it's like at this point, this is just like basically just raw search. So it's like once we combine, like this is still using AI to do the searching, but then like the next level of AI is when we combine it with like, getting the LLM to take this kind of garbage output into a real answer, like something that makes sense to the end user.
Hey, before you move on, there were 2 questions that came in on the chat. Jared asked if this product, this knowledge retrieval product, was going to be a separate tool or tied into the GPTScript CLI.
So we'll see. I mean, so like the idea, like with everything with GPTScript is like, we want to do everything kind of like external until we prove that it's useful and whatnot. Like we've got, a bunch of people working on a bunch of random things, and it's kind of like 90% of the ideas are bad. So it's like this one, if this turns out being really good, I can see this being kind of like a core thing in GPTScript. I could definitely see this kind of going in, because like this, what we're kind of finding right now is it's kind of like this database of knowledge is going to be somewhat like the way we store it and stuff is somewhat kind of like proprietary to GPTScript. Like it'll be like in a GPTScript format and whatnot. And nobody's really kind of, from what we're seeing, doing it in this style either, of like kind of being able to embed knowledge into like, so anyways, I could definitely see it going that way, but until we kind of prove that it's not a terrible idea. We won't actually include it in. So Torsten's been prototyping this. This is like, I don't know, like this is like what, like maybe like the third or fourth rewrite on doing knowledge retrieval in different ways. So this one I like the best, but it's also, you know, I liked all the previous ones too until we decided we didn't.
Yeah, very cool. And then the other question that came in off LinkedIn was someone asked, can we change the chunk size, overlap, or embeddings model in RAG here?
So I can answer that, I guess. So chunk size and overlap are currently not exposed as options, but the embedding model you can just choose via dash embedding model or using the OpenAI embedding model environment variable. By default, we're using the text embedding ADA 002 right now.
Yeah, there's tons of technical details of how to do this well, and you know, kind of with users alluding to here, like chunk size and overlap and all these things, which are really important on the quality. We're kind of prototyping right now, like kind of like what's the end-to-end user experience? Like, does this make sense? And then like if this makes sense, then we'll add all the proper technical knobs, because also like there's all this re-ranking and all this other stuff. Like honestly, I don't actually understand all of the nuances of how to do this super well. But there's a lot of people who do. So it will, if this, you know, if we keep going forward with this and we like this approach, we'll add all the knobs, of course. Yeah.
All right, Torsten, why don't you keep going with your demo?
Yeah, let's go. So first off, we're like covering the whole RAG pipeline, right? It's not only retrieval, it's from ingestion to retrieval, and that's quite a lot of steps that you have to go through. It's like finding the files, parsing the files, transforming them into a LLM readable format, which is just plain text, transforming structured data into unstructured data, and the other way around. Then sending the data to OpenAI to generate the embeddings, store them in the vector database, and then for retrieval, that's just a simple similarity search. So there's a lot going on in this tool over here. All right, so so far we've used like the default data set, but you can obviously just create multiple data sets. For example, like create a data set for your insurance documents, some other for your like law-related data set, or for work-related data, and so on and so forth. Then switch between both to retrieve relevant data. Simple example, we just create, that happens down here. I will show that again. That was too fast. So let's create a data set called foobar and then ingest the readme into that data set and retrieve from there and delete it again once we don't need it anymore. And same result as before.
So just, I mean, so what Torsten's showing is like, because under the hood, like if you run, can you run like knowledge help or whatever? Or I guess like create data set with the help. So it shows the database files.
Ah, gotcha.
Yeah, so under the hood, there's these two databases right now. There's this knowledge DB, and then there's this vector DB. So one's using SQLite, which is kind of like just a kind of a standard database, and then the other one is using this kind of custom Go library that we found. So you can have, you know, so those two kind of files is where all the data is. And so within those files, like that's what you would end up wanting to kind of package with a tool is kind of those two things. Technically the vector one is a directory, but we're going to most likely change the vector one to a different backend like a different technology. There's tons of vector databases. So these are the files that you're going to package kind of with the tool, but within those databases, you can have multiple data sets. So it's like, you know, if you want to query, like you get two separate applications or whatever. So that's what Torsten was kind of showing there is like you can have, you know, two different data sets and query them differently within the same, you know, kind of files or whatever.
Exactly, yeah. That's it. I guess I'm gonna skip on the server client setup because we don't use it too much over here, but basically it's the same thing. You spin up a server, then you set a server URL, and then can work against the remote server for retrieval, ingestion, and everything else.
So it is an option, because like everything we're saying, I've been saying, like, kind of, you're going to package these databases with the tool. It is possible to run it in a server mode and like, kind of maintain that data centrally. That's kind of interesting that you could keep updating that data. I mean, if you're really interested in, like, you want to kind of run a central server version, at that point, you might lean more towards like a full-featured vector database, Pinecone. Once you get to a certain size, it doesn't make sense to kind of use this more simple approach, like, as the data scales.
But if this is, I mean, go back to my example of the, website and details of a nonprofit, for example, in a scenario like that, where if I wanted to continually update it with the latest blogs, some kind of cron job that was sort of pulling the latest information off of the blog and adding it to the vector database, I could probably do that with GPTScript. I mean, I just have a script that was data, turning it into a PDF or turning it into text, and then, HTML to text to, pushing it into the vector database, and then allowing, say, a chat interface that was consuming that vector database to be up to date on literally even a blog that was written this week.
Yeah. So it kind of depends on, like, what's like the mechanism of how you want to deploy and stuff like that. Because, like, you can constantly be updating the database, like the data in a database, or you can be updating the data. It's like updating the data in the files and then checking those into GitHub, and then it gets shipped with the tool. So whenever someone, like, runs the tool again, it gets the latest data. So it's like, it all depends, because it's like, if you're running a website and you have like one public version, it might make sense to just keep updating, like, the central database, the central database server. Mm-hmm. But if you're doing something where it's like a tool that people are running, like, client side on their laptop, like, you don't want to have, like, sure, then everyone will have credentials and what's the security talking to it or whatever. So there's a lot more simpler use cases where it's like, it's just way easier to embed the knowledge with the tool. And then you just don't have to have, like, that additional, like, operational burden of managing a database server and all that stuff. So it's like both use cases, there's like pros and cons to both use cases.
Mm-hmm. Makes sense.
Yeah.
Very cool.
But it will totally work, like pre-training or pre-loading a data set locally and then just move it to a server and serve it from there. That will work as well. That's pretty cool because it's just a bunch of files. So right now we support all of these file types, so PDFs, HTML, some plain text formats, docx, ODT, RTF, CSV, even Jupyter notebooks and JSON. And you wouldn't believe how hard it is to properly parse PDF files. So that's crazy hard.
It's apparently a business in and of itself, just processing.
Yes, there's a lot of proprietary tools that can do it well.
Yeah.
All right. So let's go to the larger demo, and that's integrating it with GPTScript. And I've prepared the example GPTScript over here. So what does this do? After all, it just creates a new knowledge-based data set with a random unique ID. Then ingests the whole package directly, which is basically the whole code of this knowledge app, into the data set, and then asks it how I can use the CLI created from that code to ingest the current working directory into a data set. All of the tools that it uses is just sys.find to find the files, actually not required here, and all of our CLI commands for the knowledge tool. That's super fine-grained. You could actually just use knowledge and give it all the input options and it will figure out itself. So let's just run this with GPTScript. Gonna disable the cache so it's actually live. And go. Oh, where am I? Not load. Let's do it from over here. Okay. So it called the UUID gen tool to generate a unique ID so we don't have clashes in our dataset names. It creates the dataset and then calls ingest on the package path to ingest into the dataset that it created above. And you see it ingests a lot of files. And we're actually doing deduplication in the background. So if I were to run it again with the same dataset ID, it won't ingest the same files unless they have changed before. So we're keeping track of that as well. And it ingested all the 39 files into our target dataset, and now calls the retrieve tool to ask how to ingest the current working directory in the CLI. That's a lot of output that's being fed back into the LLM. And now we get an actual human readable answer, which is to ingest the current working directory into a dataset from the CLI. You can use the following command, that's ingest with an optional dataset parameter and then the path. And it even gives us some options or like some additional information on how that thing works.
So yeah, so that's cool. I just double checked. I'm like, is that even correct? It is. Yeah.
Yeah.
And this is all using OpenAI, right? GPT-4 as the backend LLM.
Exactly. Yeah. GPTScript has default. I think GPT-4 Turbo is the default model, right?
Yeah, and then for the embeddings model, yeah. So and everything we're doing works against the OpenAI, API, which there's plenty of open source implementations of. So it's like this tool, it's like this would work against local AI. It should, yeah. So I wanted to go through, so it's like, so you can see like the value here or whatever is like, we have this code base. So what Torsten just showed here is like, he just took the existing knowledge tool, but he took, basically ingested the entire code base and asked a question about it. Like, how do you do something? Which is interesting because it's just a bunch of Go code. Actually, do you think I'm trying to think what did it require? Like, do you think what did it really, do you have this written in the README somewhere? Like,
it didn't ingest the README, so even if it was there, but I don't think. Well,
I'm just trying to see if how impressive this really was. Like, so it's like for it to get that information, it pulled it out of the code.
Yeah. So the only place where this syntax is defined is the actual ingest.go, the usage string, and apparently it even extracted that the operation is non-recursive by default, just from the default value of false for the recursive flag.
Wow.
And there's actually nothing about this in the README.
Let's ask like a random question or whatever. Like,
yeah, let me quickly copy the ID.
I'm skeptical how well this will really work. It's like ask us something like, does this tool, can I create multiple data sets in a single file, something like that? Like, I don't know how it would know that. Like, I'm just kind of curious to see what it would say.
So what was the question?
Do it through your, open up your example and just change the question. Where was your question? How can I ingest?
Right there.
Yeah, change that to like, then retrieve from the knowledge base. Oh, and then like you just put the question there. Like, can I have multiple data sets in the same file? Which I don't even know if like that.
Hey, come on. AI even guessed the question. All right, I'm gonna just delete that and I'll say
delete that, because then it should run fast, right? Because like the idea is like you already ingested all of that, right? So it's like, oh no, it's gonna do a whole. Oh no, but you don't know what the data set ID is because you used a random one. Shoot.
Oh, no, it's in the output of GPTScript. So let's see if that works.
Yeah, let's try it.
All right.
Or maybe, yeah, we'll see what happens. This is always the fun. See if we can break it live.
Clear the cache too.
Well, no, like the cache is fine. You don't need to worry about that. Like
I called ingest and see.
Oh yeah, ignoring duplicates. So now, can I have multiple data? Let's see what it does. Yes. Okay, well that was strange.
Maybe how do I ingest multiple data sets?
Yeah, try that. Try that. Like,
how would I ingest multiple data sets?
Yeah.
Oh no, use the endpoint.
Oh, that's interesting. Yeah, because under the hood, it's doing. That's really interesting. So because it's like under the hood, it's a server, and so it actually found the HTTP endpoint. That's kind of impressive in and of itself. Like the fact that it like actually is looking at this Go code and.
Yeah, if I specifically target the CLI, then it does that.
To adjust multiple data, you can use the command structure. This command, the data set option states. Yeah.
Well, it doesn't return the create dataset command. That's probably because we're specifically saying ingest. So definitely the similarity score is way higher for everything. That's
So so I wanted to go like so in this example, so you can see like because what Torsten was doing was kind of like this full flow of basically create the data set, ingest, and then query it. Whereas like what we're envisioning is you would separate those into two separate things, where it's like you create and ingest the data set, and then in your GPT script, like the one you would actually deploy someone's using, then they would be doing query. And there's a comment here saying you should use this with chat mode. So GPTScript has like native chat support built in. We haven't talked about it yet. It's just kind of on main. Actually, I think it's in the last release or whatever. But like, so this is where this gets like kind of really powerful, and like we're going to be showing off the chat stuff hopefully next week. So it's like everything we're doing, like we're kind of showing you the building blocks, we're showing the different things we have, and it's really cool once you pull this all together, where it's like, once I have like a more, because it's like we were saying, like asking questions or whatever, if you're asking questions, it kind of makes a lot more sense to do that in a conversational dialogue type thing, not just write a script, ask a question, so once we pull in the kind of the chat thing, this gets really cool.
It's fun. What's interesting about this stuff, Darren, is it doesn't feel like the technical bar to do this is particularly high for a knowledge worker. Like you're not talking, I mean, you're showing here, kind of packaging up directories and packaging up code, but I mean, pointing this to a directory on my laptop or in a shared server somewhere and saying, go create this, feels like something that, almost any knowledge worker would be capable of doing, if you could abstract this up a level, right? If we can get this out of a CLI and into some other format, you could easily create these knowledge pools or knowledge sets very easily, and then leverage them in all sorts of, scripting automation functions, right? If I want to create knowledge that I don't have to educate the LLM on every time, I create that knowledge and then I reference it in my script, and I am pushing scripts pretty quickly. I mean, just as a marketer, salesperson, analyst, I feel like I'd be doing that all the time. Like it just seems like when I imagine my job in 2 years, I feel like I will be managing a dozen different sort of knowledge sets that I will want to sort of connect, maintain, continuously update. It just feels like that's going to be a part of my job, is sort of understanding context and switching context as I inform an LLM what I want it to do for me. Very, very cool.
Yeah, I mean, I think it's been fun as we've gotten into this, because it's like I like the way we've kind of packaged this knowledge thing, where I mean it's still raw. Like I mean, all of this stuff is kind of raw and early, but it's like you can see it's like these. It doesn't have to be so difficult to kind of use AI. It's like there's a lot of crazy stuff going on under the hood, but like the interaction with it is not that complicated. Whereas it's literally just like place some files in a directory and then ask questions about that.
Mm-hmm.
Then it's
yeah. I mean,
So it's like it's pretty cool.
Torsten, anything else you want to show in the demo?
No, that's actually, I think, most of it.
Excellent. This is very good work.
There's
It's
everything
really
inside.
impressive. Well, so this isn't available yet. This is not in a release that's gone out. When can people theoretically see this?
Well, you can use it. So there's actually public releases on GitHub for this.
Okay.
Just go to github.com/gptscript-ai, then knowledge, and we have the
So all
0.1.1 release.
Everything Torsten shows, this is actually already all checked into GitHub, so you can download and fool around and play with this. This example, it's all in there in the repo. So you can try this out. This will be rapidly changing. We're going to be, so it's like kind of everything about this will constantly be changing as we figure this out, kind of what we're doing here. But yeah, you can play with all of this right now, and it's fun. You can try. You just need an OpenAI key, or if you want to run something else like local AI, or I don't know if this run. I've never tried to run embeddings against Ollama. Does Ollama support embedding models? I'm not sure. But local AI is good. It's a good choice to run this against. I don't know. Torsten, have you by chance tried that?
So far, I only use it against OpenAI and our ClickyJets AI.
Yeah, I think OpenAI. I think as far as I'm not super I'm not really kind of an expert in this area, but I think they have I think that most of the stuff the open source stuff isn't really anywhere near the quality of what OpenAI has for their embedding models. But I could be wrong. No.
Oh, can't wait to see. Very cool, Torsten. Thank you so much for covering this. If anyone has any other sort of broad questions, any other GPTscript questions, feel free to fire them off in the chat. If we see them, we'll answer them. Otherwise, we'll also probably be back again next week to cover a couple new topics. So thank you everyone for attending, and we'll talk to you soon. Torsten, thanks a lot. Have a good evening.
Thank you very much. Have a good morning.
Bye, everyone.
See ya.